Let me take you deeper into the sun-dappled lagoons of a world still young, a world of liquid glass, ancient and quiet, where the first architects of life shimmer under the weak, trembling light of a pale sun. The cyanobacterial mats stretch across shallow waters like emerald velvet, undulating gently with the tides. They are the original engineers, the first civilization of Earth, capturing sunlight, producing oxygen, and laying down the chemical foundations for all life to come. For billions of years, they have ruled these waters unchallenged, perfect in their simplicity. But today, something different moves among them. Something small, something cunning, something that will alter the course of evolution forever. Episode 3, The First Hunters. Rise of the eukaryotes. These are the first eukaryotes, cells unlike anything the planet has yet seen. They are complex, compartmentalized, humming with internal machinery. Nuclei house their genetic blueprints. Mitochondria churn tirelessly, generating energy. Chloroplasts glimmer in some, capturing photons with a delicate brilliance. They do not drift aimlessly. They glide, they hunt, they engulf, they innovate. Life, for the first time, is mobile not by chance, but by design. Look closely at the Amoebozoa, slowly extending pseudopodia through the mats of oscillation. They probe the cyanobacterial filaments with deliberate intent, engulfing individual cells in silent precision. Every capture is both sustenance and experiment, testing strategies of survival that will echo through eons. They move slowly, but with purpose, aware of their surroundings, sensitive to the chemical cues of prey and predator alike. Nearby, chonoflagellates beat their collars in elegant, rhythmic sweeps, drawing in bacteria like currents funneling treasures. They are hunters and population controllers, sculpting the microscopic landscape with every captured cell. Their feeding is not random, it is an orchestration of life, subtly balancing the ecosystem, creating space for new species and new experiments in survival. Not all eukaryotes hunt. Among the drifting cells float early photosynthetic eukaryotes, their chloroplasts catching sunlight to produce energy. They coexist with predators, dancing between survival and vulnerability. Some cling to the mats, harvesting light where predatory pressure is low. Others drift in the open water, balancing feeding with evasion. Here, diversity is born, the first complex food webs taking shape in microcosm. Observe the symbiotic revolution. One eukaryote engulfs another, not to destroy, but to incorporate. Ancient bacteria become mitochondria, microscopic engines that enable power, endurance, and mobility on an unprecedented scale. Cells grow larger, move faster, and survive longer. Symbiosis here is innovation, a merging of life forms that changes the rules of existence. Across the currents, flagellated excavates dart with surprising agility. They navigate oxygen gradients, hunting bacteria and small protists with bursts of speed and precision. Ancestors of dinoflagellates glide through light-dappled waters, combining predation and photosynthesis, mastering dual lifestyles that will echo through oceanic ecosystems for billions of years. Haptophyte-like microalgae drift gracefully, harvesting sunlight while avoiding predators, balancing productivity with survival. Beneath the mats, Crucochidiopsis anchor the cyanobacterial carpets, enduring extreme heat, radiation, and drought. These resilient cells provide structural stability for eukaryotic hunters, forming a living scaffold of survival. Floating among them, anabaena chains fix nitrogen, converting atmospheric nitrogen into nutrients usable by all life. Each heterocyst releases a legacy that will feed future forests, animals, and eventually humans. The lagoon teems with microcosmic interactions. Predatory ciliates twist and spiral, sweeping bacteria with their cilia. Spirotrichs orchestrate delicate hunting strategies, generating currents that shift colonies of cyanobacteria and microbes. Each movement alters nutrient distribution, oxygen availability, and predator-prey dynamics. Every encounter is an evolutionary experiment, shaping behaviors that will persist in later organisms. Even the smallest organisms wield influence. Minute flagellates drift in shaded microzones of the mats, hunting bacteria and algae while avoiding larger predators. These microhabitats are laboratories of evolution. Species compete, adapt, and refine survival strategies. Mixotrophic eukaryotes, combining photosynthesis and predation, emerge as the first experimental trophic innovators. Their flexibility allows survival in fluctuating conditions and hints at the future complexity of multicellular ecosystems. Oxygen begins to accumulate, subtly shifting the chemistry of the lagoon. Anaerobic eukaryotes retreat or perish, while oxygen-tolerant hunters explore newly available niches. This chemical pressure drives innovation. Motility patterns change, feeding strategies evolve, and symbioses intensify. Predators must now navigate not just prey, but the environment itself, world increasingly sculpted by life. Across the mats, vortice-like ciliates anchor themselves, sweeping currents to trap prey and subtly redistribute microbial colonies. Ancestors of dinoflagellates drift between sunlit surfaces and shaded recesses, combining photosynthesis and predation in elegant balance. Slime mold-like amoebae trail along nutrient-rich corridors, consuming detritus and collaborating in temporary aggregations, testing the first forms of collective behavior. These hunters, symbionts and decomposers, are tiny, but they define their world. Euglenids swim in open waters, mixing photosynthesis with predation, adapting fluidly to oxygen-rich and oxygen-poor zones. Filamentous green algae reach upward, capturing light while feeding protozoans sample them. Every interaction, every engulfment, chase, or drift reshapes the lagoon and sets the stage for greater complexity. Predation is now central. Amoeboid predators stalk flagellates, ciliates, ambush microalgae, and even mixotrophs occasionally turn cannibalistic when resources dwindle. Each act reinforces selection pressures, refining morphology, behavior, and metabolic innovation. Symbioses multiply. Some predators house photosynthetic endosymbionts, others harbor nitrogen-fixing bacteria. Energy efficiency rises, mobility increases, and adaptation accelerates. The lagoon is a crucible of life. Oxygen bubbles from cyanobacterial mats rise like tiny crystal towers, altering gradients and forcing eukaryotes to learn precision in their hunting. Cyanobacteria, the foundation of the ecosystem, continue to thrive, yet now their reign is shared with mobile hunters, symbionts, and innovators. Nutrient cycle, predators chase, prey, hide, and symbionts cooperate all under the watchful, indifferent light of a pale sun. Observe the early ciliates again. Stentor-like cells pulse, creating microcurrents that redistribute bacteria and microalgae, shaping habitats at a microscopic scale. Flagellated algae drift past, photosynthesizing while evading capture. Amoeboid predators glide silently, pseudopodia probing every corner. Excavates zip through, feeding on small protists, avoiding oxygen-rich zones, navigating chemical cues with unmatched precision. This is an ecosystem alive with invisible strategy, the first experimental playground for multicellular potential. The nitrogen-fixing and amino chains continue their quiet work. Heterocysts released essential nutrients, fueling not only cyanobacteria mats, but also early eukaryotic predators. Oxygen rises incrementally, chemical gradients sharpen, and selection pressures refine motility, feeding, and symbiotic strategies. Evolution is immediate, visible, and relentless. Symbiotic partnerships evolve further. Mitochondria enable energy-intensive mobility, allowing predators to stalk, engulf, and explore. Mixotrophs alternate feeding modes, becoming both hunter and producer, experimenting with versatility. Small ciliates, excavates, and amoebae interact constantly, defining trophic hierarchies, predator-prey dynamics, and nutrient cycles. Every species, no matter how small, shapes the ecosystem, contributing to the foundation of multicellularity and complex food webs. The first hunters glide, stalk, and engulf with patient precision. The lagoon pulses with life predators shaping prey, prey adapting, symbionts cooperating, decomposers recycling. Every movement writes the first chapters of complexity, multicellularity, ecosystems, and eventually forests, oceans. And humans will owe their origins to these subtle, patient motions. Even as the hunters thrive, the chemical and physical environment challenges them. Oxygen gradients, sediment shifts, and nutrient availability force adaptation. Eukaryotes experiment constantly. New hunting strategies, new symbiotic relationships, new motility patterns emerge. This is evolution in action, written in living cells, visible only to those who know how to look. Stand now on the edge of the lagoon and feel the hum of life. Small, fragile, yet extraordinary, the first hunters glide past you, unseen but monumental. They are the pioneers of complexity, the architects of multicellular life. They do not know it yet, but every move they make, every prey they capture, every symbiotic union they form is a step toward forests, oceans teeming with fish, dinosaurs, mammals, and humans. The age of simple life is giving way to the age of innovation. And in these humble lagoons, the story of all life is quietly, relentlessly unfolding. Next episode 4, Dance of Molecules. This is HistoPrimordia. Thanks for watching. Subscribe, join us,